Okay, welcome to my demo. I'm Pat Stanton, and I'm in my studio at Gallery 1. And what I'm going to demonstrate is how to make, let's see if I can get this to show up. This is a ring that I've been wearing for quite a while. And it's just some basic sterling silver soldered together. And to do that, I generally start with kind of all the leftover pieces from when I've cut out other shapes. And I solder them to a strip of, this is 20 gauge sterling silver. Now it's important to understand the materials. Sterling silver is 92.5% by weight silver and 7.5% by weight copper. And that gives it some specific properties that you can read about in this book and many other books. I'm not selling this book. Sterling silver has a melting point of 1761 degrees. To attach two pieces of sterling silver, I'm going to use solder. Solder is just another alloy of silver, and it has a lower melting temperature. This one has a melting temperature of 1425 degrees Fahrenheit. So that only gives a 215 degree window where the solder will melt and flow and fuse the two pieces of sterling together. Now to heat it, I use, this is a Smith's acetylene torch. And I'll start it up so you can see what that looks like. Pretty good. Try not to burn my laptop. The acetylene is mixed with ambient air through the torch, and it burns at 2300 degrees. So let's think about this. If water boils at 212, paper burns at 451, sterling melts at 1640, and the lava coming out of Kilauea is about 2000. This is 2300 degrees. This is no joke. So we always make sure we have, luckily, I don't think we're gonna have to use it today. So I have a couple of pictures here. This is my jeweler's bench, and it's stacked on it is a bunch of leftover sterling that I've cut up for various projects. And to make this ring, I've decided to use some of the more interesting shapes. So I'm gonna actually make two rings. This one is gonna be a man's ring, and this one is gonna be a woman's ring. Now they're flat, but what's gonna happen is they're gonna be soldered together. I'm going to cut off all the stuff that sticks out above the rectangle, and then I'm going to form it together on a mandrel, piece of steel, and I'm going to solder this part here to that part there and make a ring. So let's go for it. I'm going to switch cameras. Hopefully you'll be able to see. So these are the little pieces of sterling. And what I've done is I've cut up using some clippers, the solder, into what are called chits. And they're just tiny little guys. What we're gonna do is leave the shank alone. And we're gonna melt some solder to the back of each of these pieces of silver, clean them up, and then place them on top here and heat the whole thing. Now it's important to remember that you're not actually heating the solder to make it melt. You're heating the metal and making it melt the solder, and that causes the solder to flow into the matrix of the metal. So first, a worker lights his torch and puts on his goggles. Next, the worker heats a piece of metal and to the point where the solder melts, which is a little bit of a failure on that one. There. It could be that a piece that I thought was solder was actually sterling. And I think that's what's happened. Now when the solder melts, I place it into water. Water has a high specific temperature, which is a fancy way of saying that it takes a lot of energy to change the temperature of water. And we use that to our advantage here to quench the silver. All those little guys have melted. And as soon as it touches the water, it's cooled at the touch. This is the basic concept. So I'm going to do a couple more. So I'm not sure if anybody can see this, and I'd like you to be able to see. So the sterling is now heating up, and as soon as it reaches 1425, solder melts into the pickle. And to prove, this is a piece of sterling. I know it to be sterling. And I just melted it into a ball. So that tiny little window is the skill that's required to make this all work. Knowing the physical properties of the metal. Let's see if I can get a few more of these to melt. Now, what I skipped there, the white stuff is the flux, and its purpose is to prevent the products of combustion and oxidation from making the metal dirty. The metal gets dirty, the solder will flow, and it will attach itself to the dirt. The flux is basically soap, and it is creating a barrier to oxygen. So believe it or not, this is how it's done. These tiny little pieces of solder. I left the flux out in some of those, hoping that you could see solder actually flowing. And because the flux is water-based, as soon as you start to heat it, it boils, and then the solder chits bounce all around, and it is, there's no end to the fun in that, because you get them perfectly placed, and then they bounce around. Let me see, I'm gonna get one more here. Hopefully you can see this. There they went. Okay. Torch off. Now, everything here you have to assume is very hot. Torch has been heating it at 2300 degrees, So you don't really want to reach in and touch anything. These are fire bricks, and they're designed to reflect the heat and not absorb it, but they can still get hot enough to burn you. And you want to make sure to never have anything combustible, like a webcam around your solder station. So just like Betty Crocker, I have one here. This is the ladies' ring that I was working on. And I came in earlier and I melted solder onto the back of each of these pieces. We're making like a peanut butter and jelly sandwich. We need enough solder in between to fill the void between the two pieces of metal. Too much and then it comes out everywhere. And that's no good either. Now, this is going to take longer because there's more metal here. The torch is still the same temperature, it's just going to be absorbed more by the metal. Now, this is where it gets very tedious because I've let the flux mostly evaporate, meaning let the water dry out. But everything still starts to move around. And so I reach in with these stainless steel tweezers and I kind of touch everything and make sure it's kind of in place where I want. Oops. Kind of par for the course, it's very normal. Now, one thing to be careful of is that the tweezers themselves start to get very hot. So you can dip them in the water, grab a different pair of tweezers. Could cry, could write your congressman, but that's how it goes. Now this, I wanted a little different spot, so I'll kind of give it a little kick. And pretty soon, it'll start to be a little red, and then there'll be little greens and blues. Those are cupric oxides. Let's see if we can get the solder to flow here. And what you should see when it works is a little flash, and the gravity should cause the sterling to fall against the piece below it, for the most part. If they're super bent, that's not going to work. Now remember, you also have to do all this without breaching that 215-degree window of opportunity between the temperature that the solder melts at and the temperature that the sterling melts at. Because if you do, you end up with a big ball of metal instead of an artwork. This one is starting to be a little frustrating. And this piece is not quite soldered, I don't believe. See, it just came out. So I'm trying to heat up from below, because I think the problem is the piece on top is getting hot, and not the piece on the bottom. And we need both pieces of metal to approach the soldering temperature for the magic to happen. So this is an incredibly tedious hobby. Pretty rewarding. Every time something solders, it's almost like magic to me. And I'd sure like my demo to be somewhat successful here. Let's hope the magic happens. There we go, that one is soldered. That one is soldered. I'm moving the torch around because I don't want any one part of the metal to get too hot. I'm trying to make sure that the entire piece approaches the soldering temperature. And I think I'm just about there. Okay. Now, that was all, everything was at 1640. And instead of being a whole bunch of little pieces of metal now, it is one solid mass. And it's super hot. So, put it in the water, and you can see that everything is attached. And mostly where I wanted it to be. But on the back, since I didn't put any flux, this is the products of combustion, the part that, the dirt that I didn't want to get in the way of the solder seams inside. So it's super dirty, kind of cool with glue. Over here, let's see if we can see this on the webcam. I have a crock pot from Goodwill, and it has hot water. In the hot water, mind that, is just some swimming pool chemicals. What we need is a weekly acidic bath. It's called pickle because many years ago, they would have used vinegar as weekly acidic. Here are some of the other products that I've been using. This is the flux. None of these chemicals themselves are dangerous. Tastes a little salty. The torch is the most dangerous. And then forgetting what you've been doing and putting your hand on the brick or a piece of metal that's next to it. So this one was sitting there as I was soldering, and I am sure that it is hot. So what I've done is soldered a top piece, or in that case, 20 little tiny pieces. And once they become a solid mass, the next step is to take a mandrel, and by striking it, I can bend the metal around it. But there's another piece there that's important to understand. The metal from the factory is pretty stiff. You can order it as half hard, hard, soft. But usually it's pretty stiff. And what that is called work hardening. The atoms are all packed together, just like if you bend a paperclip back and forth enough, that one little spot that gets bent enough becomes rigid and breaks. To be able to bend it, what you need to do, and that book I was showing will explain it, you need to be able to heat it to half of the melting point. Let's go back to the other camera here. Come on. So half of the melting point is what's called the annealing temperature. And that is the temperature at which the atoms, the matrix opens up and the atoms can move around a little bit. The metal does get noticeably a little bigger. I always wondered that. So I tried it out. Now this is the ring that the ring blank. And as I was bending that other piece of sterling, it didn't want to bend. This one will easily bend. And so once I get the size and shape that I want on the mandrel, in fact, I can actually just kind of bend it with my fingers around the mandrel and start to get it closer. So those are the basics of soldering. I made myself some notes. I think that if you're going to try this out yourself at home, I say go for it. Make sure you have a fire extinguisher, some sort of eye protection. Get yourself a few books and read about the physics and the chemistry and the history of the jeweler's craft, because it is interesting. And one last piece of advice to somebody who's going to try this out at home: when you buy solder, the catalog says it's easy, medium, or hard. And most novices would think, I want to use the easy, right? Why would I want to start with the hard? Those are really crummy names. What they indicate is the temperature at which they flow. Easy solder flows at a much lower temperature, something like 1340. But it also is an alloy that has a lot of metals that are not copper and silver, tin, and I think, I don't want to say it, but it is not as good of a product. The reason that there are three different, well, it is a good product, but the reason there are three different solders is, let's say you soldered these two together using hard solder. Now you know that as soon as the piece reached 1640, that solder would flow and everything would move around. And let's say you wanted to add one more little piece. Well, you could reach for medium solder, which melts at 1500. And you could solder something to it without risking loosening up the joint you've already made. And if you added another thing that you wanted to add, you could go to the easy. I've abandoned all that. I do everything in hard. I think you get a better joint because the hard solder actually flows into the matrix of silver. The key to being able to do that is to learn how to control the torch and practice. So that's my demo. And thanks for tuning in. I'm going to record myself bending the shank into shape, soldering it together, and then I probably spent another 10 hours filing and sanding and buffing and shining because it's my hobby and that's what I do. So that is pretty much all I have.